Hello guys. Let's talk about the question 8 in the homework 3. Uh, what is the data? Alright. So we'll get the data here. LU is the basic CPI or ideal CPI, okay? And the load and store is 2, the branch is 0.5 and the jump is 0.5. And the percentage is I mean how many kind of the yeah just the instruction happened is 20% load and store and 20% branches and 10% of the jumps, and we have 50% of the algorithm ALU unit. Okay, so here is the basic information. So go to the part A. Four-way set. Okay, one level separate data and instruction cage. Oh my god. Okay, with a miss rate for 10%. So here we will have a data with miss rate is 10% and separate data and instruction cage. Oh, cool. And instruction, the miss rate will be 5%. Okay. A miss penalty of 40 cycles for both. Okay. And miss penalty is 40 cycles. 40, okay. And the hit, they are both 1 cycle. Okay, good. What is the effective CPU? Okay. And AMAT, right? So we need to calculate CPU and AMAT. Okay, firstly, let me get the CPU. Okay, so you remember CPU will contribute with each kind of instructions. So firstly, we want the ideal CPI. Here is the ideal CPI. Uh, let me just put CPU here. And CPI ideal will be the one with 1, right? 1 with 50%, and 2 with 20%, and 0.5 with 20%, and 0.5 with 10%. And this will give us 0.35 cycles. And here is the ideal thing, right? But actually, when we calculate the CPU, we need to consider the stores. So you remember here we will have stores for like data and instructions miss, right? Yeah, the table is kind of like this. So yeah, we will want to get the data miss, data miss penalty, and instruction miss penalty. So they are kind of two things. Yeah. Okay. So firstly is how the rate for data access. Okay. For data access, the data access is actually just a load and store. So it is 20% will be a data miss or yeah, something. So kind of the stores will happen is that for data miss penalty panel, or you can say the stores should go with 20% of the instructions and 10% of the miss, and with the 40 cycle go to the main memory, and this will give us what? Oops, will give us 0.8, right? 0.8 cycles. And how about the instructions? So instructions will happen for every instruction. It's not that data is an instruction, right? So you should also include the data. So instruction is totally 100%. Data is the 20%. So here is the instruction miss penalty stores. We will have 100% of the instruction with 5% of the miss and 40 stores. So here it will give us like 2. So what is the result? The result is 2.8. That is the stores when we have when we have the miss. So how about the CPI now? CPI now or with stores. That is the ideal CPI with the kind of the stores. So it will give us 4.15 cycles. Is that okay? Yeah, the effective CPI with memory stores. Memory stores, the ideal CPI, and here is the effective CPI. Okay, so the next is the AMAT. Average main memory access time. Okay, so actually, since we are splitting we need to consider the data and instructions. So how many access we will have? Actually, here is the 20%, here is the 100%. So actually, we have you can consider it as 120% of the fetch from the main memory. Yeah, the instruction we need to fetch. The data we also need to fetch. So totally is the 120%. Okay, and the MAT. So like for data part plus the instruction part, right? Data part, how many kind of the fetch is for data? So yeah, it's 20 of the 120, right? And we use the MAT is one is the hit and we have 10% of the miss and with 40 the penalty. And also we have the instructions that is 100 of 120. One is the hit and 5% of the miss with 40 penalty. And this will give us 3.33 cycles. And here is the MAT. All right, let's go to the part B. Two level, right? Two level, so we will have kind of two cage. Level, okay. L1 is the miss rate is 15%, and the L2 is the I think it's a typo. It's 40%, and the hit time in the L1 is 1 cycle. Miss penalty, miss and hit. Also that hit is 10 cycle for L2, right? Yeah, if we miss in the L1 and hit in L2. So this is kind of the data we have, and it's a 2 level. Assume miss penalty is 40 cycle. Oh my god. So miss penalty will be 40 cycle. That means we will go, if we miss in L2, we'll go to the main memory, right? That is actually the hit in main memory. They are the same. These two are the same thing. And yeah, what we want drives the equation of the CPU time effective CPI and the AMAT. Okay? Okay. All right. And remember, we will still have this kind of table, right? Yeah. Yeah. Still considering, are we still considering the data and instructions? Yeah, sure. Okay. So now let's talk about the AMAT. Okay, so like heat will be 1, and miss is 15%, miss in L1, and heat is 10 cycle for L2, and plus 40% is miss in L2, and with a hit or in the main memory, yeah, or the miss penalty in L2, yeah, here will give us 4.9 cycles. So how about the effect CPIs or the CPU time? So we'll consider the CPI, effective CPI to be the ideal CPI plus 50 stores, kind of the stores. Okay. So let's talk about the stores here, right? Stores actually means the uh, main memory stores from the instructions. But since we will fetch for data and instructions, so totally, let's say total is like 120%, and how many is for instructions is 100%. So the percentage of the memory fetch per instruction should be, here is the stores, right? Should be 120. This is the totally, and per instructions. So instruction is 100. So this is kind of the instruction, the main memory fetch per instructions. Yeah, per instructions. So and then we will go to calculate the stores. Stores is doing the same thing. Uh, just this part, right? So this part you just need 4.9 minus 1. Yeah, we can get this part. So it's 1.2 multiplied by 3.9. Let me use my calculator. Okay, it's 4.68. Yeah, so this is the average memory stores per instructions. And yeah, we need to calculate the effective CPI, right? The ideal CPI is, let me see, here is 1.35, 1.35 plus our stores, 4.68. Here we'll get 6.03, right? 6.03 cycles. And yeah, here is the part B. And remember, we still have like kind of part C. That is compare which one is better. And this effective CPI here is, oops, 6.03. And what is part A? Part A is the here 4.15. So oops, 4.15 is part A. Whereas part B is 6.03. So surely part A is better, right? Yeah. So that is the question for question 9, question 8. Yeah, the most important is you need to split your memory fetch into the data part and instruction part, and the combination will be 120%, not just 100%. I think we have mentioned it before in question in homework 2 or any other place. I don't remember. But this kind of idea just happened time to time. So you need to understand it, right? Okay, thank you.